Welcome to the section of this course. Today I will be speaking about partial fractions of integrations and its concept and its tricks how to get the short answers within few minutes. Okay. Now, why the partial fraction is introduced in the integral? Because this type of integration, if for example, if I have integral of Now, if I have integral of 1 upon x minus a into x minus b, this type of integral, it is of the form polynomial where fx upon gx. Okay, let's say where gx is not equal to 0. Now here, if this type of integral, if we substitute x equal to some trigonometric function also, it will be very much difficult to solve this type of integrations. Okay. Therefore, this type of integrations, what you used to do, we used to take with the help of partial fractions, then integrate. Okay, means we assign some arbitrary constants a and b in associated with the algebraic functions polynomial differently, and then we solve. After that, we solve with the help of partial fraction by finding arbitrary constants. Okay. Now the partial fraction, for example, if I have integral of is, for example, fx upon gx, where gx is not equals to 0, meaning if I have integral of fx upon gx, where gx is not equals to 0, then this type of rational functions, okay, how to integrate. So for this, we need to see some concept. Okay, here we have this numerator and denominator. The order of gx should be strictly greater than order of f of x. Okay, order of x. For partial fractions, for solving partial fractions, okay, the order of gx should be strictly greater than the order of fx. Okay, then these above integral are these are fractions we call proper fractions. Okay, proper fractions. Now partial fraction is applicable only you have proper fractions. Okay, meaning these gx, here numerator, denominator, the order of denominator should be strictly greater than order of numerator. For example, I have integral of, say for example, x square upon x4 plus 5x cube plus 1. Now here, the order of gx is what? 4. Okay, the order of gx is 4 and order of f of x is what? 2. Okay, now this is greater than this, order of this is greater than order of this. Okay, order of this polynomial. Therefore, we call that is called proper fraction. Then we can apply partial fractions. Okay. Now, if it is in case, okay, if order of order of fx, okay, if order of fx is greater than or equals to order of gx. Okay, now order of fx is greater than or equals to of order of gx, then what we have to do is we have to follow what? The algorithm of division rule. Then you will get in terms of proper fractions. For example, if I have integral of for example x square plus 5x plus 6 upon x minus 1, okay, x minus 3, let's say. Here this polynomial, the order of this polynomial is what? 2. The order of this polynomial is 1. Okay, 2 is greater than 1. Okay, now here order of fx is greater than order of gx. Okay, now in this case we have to divide this polynomial by this polynomial. Okay, and then you'll have by using algorithm of division, and then you'll come to the proper fractions. It means you will bring to the order of gx will be greater than order of fx. Okay, this type of integration is called improper fractions. Improper fractions. For improper fractions, what you have to do is you have to use algorithm of. For improper fractions, what we have to do is we have to use algorithm of division. Then use partial fraction. Okay. Now here for this you can use directly partial fraction. Okay. Now there are some formats for partial fractions. Number one. Okay, if it is linear and non-repeated. If it is linear and non-repeated. Fraction. Number one case, if it is linear and non-repeated fractions. Okay, for example, if we have 1 upon, for example, x minus a, x minus b. Okay, these type of integrations, what we have to do is, these type of integrations, if they have given, solve this with respect to x. Okay, now consider, remove this integration. Okay, consider this equals to, it is linear. Okay, x raised to 1 is linear, x raised to 1 also here linear. Okay, here is non-repeated. Here this same term is not repeated over here. Okay, this is linear and non-repeated fractions. Okay, now these are all for what? Proper fractions. Okay, this is for proper fractions. Proper fraction. Okay, as I told you, if it is improper fractions, then you cannot apply directly partial fractions. You have to bring into the proper fractions by division algorithm, and then after that you have to use these formats. Okay, these are all formats. Okay, now this we have to assign arbitrary constants a upon with these algebraic functions x minus a plus this is over, and assign b upon is upon x minus b. Okay, these are linear and non-repeated fractions. Okay, now if it is linear and repeated functions. Okay, now second case, if the fraction is linear and repeated fraction. Say for example, linear and repeated. For example, if I have 1 upon x minus c the whole square into x minus p. Okay, here here this is linear. Okay, here x raised to what? X raised to 1. Here also x raised to 1. Okay, but this term is linear, this other term also linear, but here you can see x minus c the whole square is repeating 2 times. Okay, therefore we call this is linear and repeated functions. Okay, these are functions. What we have to do is this, for let's see this. Okay, here choose arbitrary constants. You have to find out a upon x minus p plus, you already assign a, come back to another next arbitrary constants b, here x minus c. Okay, you have to go up to the highest power of what we have assigned. Okay, after with arbitrary constants c x minus, here if you confuse c, then you can write over here, let's see, this is x minus q. Okay, here write x minus p. Okay, here x minus q, and then x minus q the whole square. Okay, if it is repeated. Okay, now what we do, a upon x minus p here. Okay, and then b for this b upon x minus q, c upon x minus q the whole square. You keep on increasing until you get the highest. Okay. For example, if I have, this is cube. For example, if I have 1 upon x minus q raised to cube x minus p, then what we have to do is a upon x minus p plus b upon x minus q the whole one, or you can say keep it to this, c upon x minus q the whole square. What we have to go up to what, 3 till the highest power. Okay, cd with arbitrary constants, c upon x minus q the whole cube. Okay, now this is linear and repeated functions. Okay, now if it is quadratic form, okay, if it is quadratic, 3, it is quadratic, QEADRA, quadratic fractions, say non-repeated. Okay, here you can say non-repeated, non-repeated. For example, if I have 1 upon x minus a, here x square plus say twice x plus 1. Okay, here is quadratic function. Okay, here is quadratic function, here is linear function. Okay, for this linear function you assign a upon here x minus a plus, since we have quadratic functions, okay, we have to do what, bx plus c upon x square plus twice x plus 1. Okay, here see the highest power, here the quadratic is there, so you have to assign another x plus some constant. Okay, this is the quadratic functions for non-repeated. Okay, if it is repeated, okay, for example, if it is repeated, then what I have to do, if it is repeated, let's see, if it is repeated over here, okay, next I will write over here 1 upon x minus a x square plus twice x plus 1 the whole square. Okay, same as a upon x minus a plus here. Okay, here we have to assign x square plus twice x plus 1 for this bx, similarly bx plus c plus another is what, you have to write x square plus twice x plus 1 raised to whole square till you get the highest power. Okay, now here again you have to assign the arbitrary constants. We have c up to c here, dx plus e. Okay, now these are the some formats for the fractions. If it is this way, you have to do this. If it is linear and repeated, you repeat till you get highest power. If it is quadratic functions, non-repeated, this is for repeated. Okay, repeated quadratic function. Okay.